Hello my dear students, how are you today? Today we'll continue our second lesson in this term and talk about matter construction part 1, unit 1, lesson 2, part 1. Let's start. Previously we learned what's meant by matter, and matter is anything has mass and volume. So what is the matter composed of? The matter is composed of molecules. The molecules are smaller building unit for the matter. Okay, the molecule here has the properties of the matter. Let's see this activity. If I have a bottle of perfume and I measure it on the scale and I will find its mass, for example here 90 gram. When I open the bottle of perfume for a while and leave it for a while and measure its mass again, I will find what? I will find that the smell of perfume spread all over the room and the mass of the bottle of perfume decreased. Why? I didn't take anything from the bottle of perfume, but why that the mass of the bottle of perfume decrease and the smell of the bottle of perfume increase or spread all over the room? First, that the matter here is composed of molecules, and the molecules have the same properties of the matter. And the matter in any state, solid, liquid, or the gaseous state, is of a small building unit, and this building unit called molecules. So molecules are small building units of the matter, and it has the properties of the matter. And the molecules is the smallest building unit of matter which can exist freely. Again, the molecules is the smallest building unit of matter which can exist freely. As the matter before, that the matter has properties, also the molecules here has also properties. What are the properties of molecules? First, that the molecules are in a state of continuous motion in all directions. The second property, that there are intermolecular space between the molecules of the matter. The third property, there are attraction forces between the molecules of the matter. Before we study it, let's see these two terms, the intermolecular space and intermolecular force, to remember them later. The intermolecular space, these are the space between the molecules of the matter, while the intermolecular force is the force that connects the molecules of the matter together. Again, the intermolecular space, the space between the molecules of the matter, while the intermolecular force, that is the force which connects the molecules of matter together. Let's see this activity to be sure that the molecules are in continuous motion. As we see here, when we put the ink in the water here, the ink spread in all the water without moving it. Why? Because of what? Because of that the molecules are in continuous motion. The molecules are in continuous motion. The second property, that between the molecules there intermolecular space. Let's see. If I have here 150 milliliter of water in a container or in a graduated cylinder, while in the second cylinder, as we see here, 100 milliliter of ethyl alcohol. By adding the ethyl alcohol and the water, the total volume should be the summation of the both of their volumes, means 150 plus 100. This should be the volume I should get. But as we see here in the graduated cylinder, when I pour the ethyl alcohol to the water, the total volume is less than 250. Why? Because there are spaces between the molecules of the matter. From this we conclude that the intermolecular space between the molecules of matter, the ethyl alcohol or the alcohol fill the intermolecular space between the water, so the total volume is less than the summation of both of them. The third property, that there are intermolecular force between the molecules of the matter. Try to divide or try to break the piece of iron and try to divide an amount of water. As we see here, that it's difficult to break the piece of iron. Why? Because the piece of iron is the force between their molecule or its molecules are very strong, so it's difficult to break that piece of iron. While the water here, its intermolecular force between its molecules are weak, so it's easy to divide the amount of water. From this we conclude there are intermolecular force or attraction force among the molecules of matter. If I asked you here, why when you put a drop of ink in the water it spreads? Why the water spread the drop of ink? Because the ink molecules have continuous motion in all directions. The second one, it's hard to break an iron rod. Why? Because the iron has very strong intermolecular force. The third one here, it's easy to make an amount of water into portions. Why? Because they have weak intermolecular force. While the gaseous have indefinite volume and shape, because gaseous have very weak intermolecular force. Let's see a quick comparison between the solid, liquid and the gaseous state according to the motion, the intermolecular space, intermolecular force, and the volume and the shape. Let's start with the solid. As we see here, the motion of the solid vibrate limited vibration, the intermolecular space very narrow, the intermolecular force very strong, while it has a definite volume, definite shape. While the liquid, as we see here, that it slide past each other, or its motion is free. The intermolecular spaces is far, while the intermolecular forces is weak, and it has definite volume and indefinite shape. Means that the water takes the shape of the container. Again, the water take the shape of the container. While the gaseous state here, as we see in this video or in this picture, it's randomly or completely free. The intermolecular space very far, while the intermolecular force very weak, and the volume, it has indefinite volume and indefinite shape. It takes the shape and the volume of the container. It takes the shape and the volume of what? Of the container. The relation between the temperature of the matter and its physical state. What makes the matter change from one state to another? Starting with melting, we studied in the last lesson. Melting means the change of matter from the solid state to liquid state by heating. And also here, the matter changes from the solid state to liquid state by heating. Why? Why the matter changes from the solid to liquid by heat? When we heat the molecules gain energy. Again, when we heat the molecules gain energy. When the molecules gain energy, when you gain energy, you can easily run to move all around. Also, the molecules, when it gain energy, it move faster. And the space increase, so it changes to liquid. Again, when the molecules gain energy, it move faster, it move away from each other faster, and the space between the molecules increase, so it change to the liquid state. The second is vaporization. Vaporization is the change of the matter from the liquid state to gaseous state by heating. If I asked you also here, the matter changes from the liquid state to the gaseous state by heating. Why? It's the same as we said before. When the molecules gain energy, it moves faster and it go away from each other and it changes into gaseous. So that's it for today. Thank you for watching, and if you need anything, you can reach us by logging into any of the social media accounts by scanning the QR code that you find in the end of this video, or you can contact to me directly to my WhatsApp by scanning the QR code and contact with me directly. And don't forget to share this video with your friends if you like it, and subscribe the YouTube channel. Thank you for watching. See you next time, and goodbye.